Alright, so for this video we're going to address the determining empirical formulas worksheet, and I'm going to take you through each one of these problems in the next couple of minutes, and hopefully that helps you understand how you can determine those empirical formulas given the percentages. Alright, so when we're determining empirical formulas from percent composition, we are going to deal with three simple steps. Step 1 is to change percent to grams. In step 2, we're now changing those grams to moles, and we're going to do that by using the mole formula. And I wrote the mole formula down for you right there, but you can always find it on your reference tables. And then finally, we have step 3, where we're setting up a mole ratio and dividing by the lowest number to make a whole number subscript. Alright, in this first question, this is the question that I did in class as well. We're going to find the empirical formula for something that has 75% carbon and 25% hydrogen. So for step 1, you can see, I've been working all day on figuring out how to get this to go bigger and smaller. In step 1, we changed the percent to grams. That's all I did, was I took this percent symbol and I changed it to grams. In step 2, what we're going to do is we're going to change grams to moles. And the way we do that is with the mole formula. Moles equals grams over gram formula mass. So to do this, we're going to take 75 grams for the carbon, that one, and we're going to place it over the gram formula mass of carbon, which is 12 grams per mole. And we're going to end up with 6.25 moles of carbon. And to do the hydrogen, we're going to take 25 grams of hydrogen divided by the gram formula mass of hydrogen, which is 1 gram per mole. And we're going to end up with 25 moles of hydrogen. And then the last step is just to set up the mole ratio. I'll do that with a black pen. I'll take my carbon. I'll put 6.25 moles for carbon, and hydrogen got 25 moles. And these two numbers, this one right here and this one right here, have to be simplified so that we get the lowest whole number ratio for our subscripts. So what we'll do is we'll take the smaller number, which is 6.25, and divide both of them by that number. And we're going to get 1 as our subscript for carbon, and hydrogen is going to have a subscript of 4. 25 divided by 6.25. Alright, so this one, for step 1, all we're going to do is we're going to take the 52.7% potassium and make it 52.7 grams of potassium, and 47.3% chlorine. We're going to make it 47.3 grams of chlorine. That takes care of step 1. For the next step, we're going to change grams to moles using our mole conversion formula. For this step, all I did was I took the grams, just like in the formula, it's up on top. I took the gram formula mass of the element that I'm looking at. I divided them, and I got moles of potassium to be 1.35, and I've got 1.33 moles of chlorine. And finally, for step 3, what we have to do is we have to make a mole ratio. So we'll do potassium is 1.35, chlorine is 1.33. These are not whole numbers, so we're going to divide by the smaller number, which is 1.33, 1.33, and we're going to get potassium is 1, chlorine is 1. Alright, on question 3, we're going to do each step, and I just did step 1. I took the percent and I changed it to grams. I took the percent, I changed it to grams. I took the percent, I changed it to grams. Everything else is exactly the same. Now I'm going to do step 2, and in step 2, again, we're taking the mole formula and we're changing grams into moles. Alright, on this first one, we're going to take 21 grams of aluminum. We're going to divide it by the molar mass of aluminum, which is 27 grams per mole. And we are going to end up with, we will end up with 0.78 moles of aluminum. For this next one, I took the 25.4 grams of phosphorus. I divided it by what phosphorus weighed, and I rounded it to the nearest whole number, so I got 31, and I ended up with 0.82 moles of phosphorus. All right, and then this last one I did 52.5. I got that 52.5 from right there. I divided it by 16 grams per mole, which is the mass of oxygen, and I got 3.3 moles of oxygen. Okay, now I'm going to go on to step 3, and that means we have to make a mole ratio. And we know that aluminum is 0.78 moles. We know that phosphorus is 0.82 moles, and oxygen is 3.3 moles. Now these are the subscripts, but they're not whole numbers. So we have to do the very last thing, which is to divide everything by the smallest number. And 0.78 is our smallest number. And we're going to get Al1P1O4. So our empirical formula reads AlPO4. That's a 4. Okay? Make a smiley face. Feel good about yourself. Okay, for the next couple, this magnesium and this bromine one, I'm just going to do the work, and I'm going to post it up here, and hopefully you follow along with me so that it's not a very long video, but you can see the answers. So as you can see, I just did step 1 and step 2, and I got moles of magnesium, and I got moles of bromine. I made my mole ratio 0.54, and I got that from here. I made my bromine 1.08. They're not whole numbers, so I'm going to divide by the smallest one, and I'm going to end up with magnesium 1, bromine 2. Alright, so this one I'm just going to do real quick, and hopefully you're following along with this video. If you have any questions, make sure you see me during class. Alright, so in the second step here, I calculated the moles of sodium, right here, and the moles of sulfur, and the moles of oxygen. Now I'm going to set up my mole ratio, and you can see that these numbers are not whole numbers, so we're going to divide each one of those by the smallest one, which happens to be 0.7. When we do that, we're going to get Na2S1O4. And there's your empirical formula. Alright, I'll spend a little bit more time on this one because this one's a little different in that if you look up here, they gave you 36.1% water. And water is not a single element, so you have to treat it as the compound that it is. So I'm going to work through this one. I'll pause and tell you how I'm doing it as we go along. Okay, I'm trying to squeeze these all on here so you can see what I'm doing, but I set it up exactly the same way. I have grams over gram formula mass. This is going to give me my moles, and I'm going to write them underneath just for a lack of someplace else to write the answers. So this one, the copper, turns out to be 0.40 moles of copper. The sulfur is also 0.40 moles of sulfur. The oxygen is 1.6 moles of oxygen. And finally, the water is 2 moles of H2O. All right, that's my mole ratio. So I have copper with a 0.4. I have sulfur with a 0.4. I have oxygen with a 1.6. And I have water, which is, if you recognize it, it's a hydrate, right? Because we have the copper and the sulfur and the oxygen, which is going to make up our salt compound, and we have the water over here that we're going to deal with as if it's a hydrate. So this H2O, I can put the 2 moles down here and put that in parentheses so that you know that there's 2. But what's going to happen is when we divide through by the smallest number, let me get a different color pen so you can see what I'm writing now, 0.4, 0.4, 0.4, and 0.4, I'm going to end up with a ratio of copper 1, sulfur 1, oxygen 4, and then I'm going to end up with 5 H2Os. Well, we're not going to write the 5 as a subscript because there's 5 of that whole unit of water. So how we would write it would be just like we've seen in the past. This is the copper 2 sulfate with 5 H2Os.